Hello. So in this video, I'm sorry, not discovering here. I will cover two rules we use to tackle taking the derivative of a bit more complex functions than the more basic rules we have for derivative, right? So the first rule we have is called product rule. And we kind of use this when we're trying to find the derivative of the product of two functions, or what looks like the product of two functions, right? So it's two functions, f of x and g of x. And we know that this is equal to f prime of x times g of x plus f of x times g prime of x. So that can be a little confusing. And like, what is f of x and g of x? So let's say we had some function. I'll give it p just for sake of simplicity, and trying to avoid confusion here. So let's say p, the function p of x, equals x squared times sine of x. So the first step here would kind of define our sort of two sub-functions, if you could say. So you'd say that f of x would equal x squared, and g of x would equal cosine of x. No, I'm sorry, sine of x. We're not taking the derivative yet. I got a little ahead of myself there, right? Because this function is kind of like the product of two sub-functions in a way. So if we wanted to find p prime of x, we would just follow this formula, right? So we take the derivative of this product of functions. And this product of functions right here. So let's define f prime of x and g prime of x, right? Because if you see, we need that to work with this rule. So x squared, the derivative of that would be 2x using power rule. And then g prime of x, if g of x equals sine of x, if equals sine of x, right? The derivative of that, according to the sine rule, would be cosine x. So now we have every little piece, f of x, g of x, f prime of x, g prime of x, to solve for p prime of x. And according to the formula, it's f prime of x, 2x times g of x sine x plus f of x squared times cosine x. And that would be the derivative of p of x. So that is the product rule. And if it's scary, just know that it takes practice. It takes solving problems to get used to. Eventually, it'll become just second nature, right? So the next rule I'll be discussing is basically the opposite of this. So the first one kind of discussed what happens if we have the product of functions. And this next one is what we call quotient rule. And that's when we have basically this quotient of two functions, right? So we have one function divided by another function. And again, usually f and x are usually this more simpler functions. Like polynomials and e to the x, stuff like that. So what this derivative ends up being is g of x times f prime of x minus f of x times g prime of x over, it's not g of x actually, it's actually over g of x squared. Now, again, I don't really know the actual proof and derivation of this rule. I just know what it is. If that's something that you're interested in, you could probably find a YouTube video on that. I'm sure there's plenty of sources out there on the kind of proof of this. But as for like memorizing this rule, because it's very much more specific rule. You're subtracting these two products, so this order is very important too when you're taking the square of the bottom. I kind of remember it as this. I say d dx, right? The derivative, and I think of f of x and g of x as a numerator and denominator, right? So we call this high and low, just for like a little mnemonic device. And we say the derivative is low d high minus high d low over low squared. So low d high minus high d low over low squared. It's like a nice little rhythm to it. And that's kind of how we use to memorize it. So let's go through a practice problem. Just kind of see how it's used. So let's say we had x cubed over e to the x. If we wanted to find the derivative of that function, we have to use the quotient rule. So let's define f and g of x, just so we can kind of see how it all comes together. So f of x would be x cubed, right? In this one, it actually matters a lot what you use f and x and g of x. Usually we use like this. If you wanted to think of the quotient rule as g of x over f of x, that's okay. Just make sure when you define f of x and g of x, that one of them is the denominator and one of them is the numerator. And it follows low d high minus high d low over low squared. So we defined f of x as x cubed and g of x equals e to the x. So we also need f prime of x and that would equal 3x squared, right? According to the power rule. And then g prime of x. Well, if g prime of x is e to the x, or if g of x is e to the x and g prime of x is also e to the x. And we'll define g squared right now too. So g of x squared would equal e to x, right? Because you multiply that exponent, right? Because e to the x squared would equal e to the x. So now we have low d high minus high d low over low squared. So let's write that. So we have low d high, so low d high minus high d low. Let me write that better. That was supposed to be a 3 on top. Over low squared. And that would be the derivative of this function. So now I want to run through one bit more complex problem that involves actually both rules. So let's say we had so let's say we had 4x times sine of x over, let's say, ln of x. So let's define our top and bottom. So let's say f of x is 4x sine x. But if you look at this, you might realize, hey, this itself is a product of functions. So if we want to find the derivative of this, which we will in a second, we have to use a product rule. But first, let's define g of x, which is just ln of x, right? It's that numerator. So if we want to find the derivative of this function, I would need f prime of x. And I'm just going to do this real quickly, but that would be the derivative of this, so 4 times that original function, sine of x, plus that original function there, so 4x, times the derivative of this, so cosine x. So that would be f prime of x. So when we use f prime of x in this quotient of quotient rule formula, we will actually substitute in this value. And then g prime of x would actually equal 1 over x, right? So now let's go through this. We have low d high, which is this f prime function. I cannot write an x for the life of me. So we have low, which is ln of x, times d high, which I'll just copy and paste this little function over. Oh, seem to lost a few lines there. That's okay. Let me just correct this. So use sine x. So be that derivative function minus high d low 4x sine x times d low. So low d high minus high d low, which is 1 over x. Which actually, cancels out. So it can help to do a little bit of algebra to make it look a little cleaner. So that x and that 1 over x actually end up canceling out. So we're just left with 4 sine x right there. If that makes sense, I hope you kind of follow along what I did there, that cancellation. So that x from the original function of f, that 4 times x, canceled out with the function g prime of x, right? And that leaves us with 4 times sine of x. And that's over ln of x squared. And that's actually as simple as we can get it. You might want to say, oh, but we can cancel out this ln of x. We can't, because we have this minus 4 sine x term in top that doesn't have an ln of x in it. So we couldn't cancel out any ln of x's. So that's actually probably as simple as we're going to get this function without distributing this ln of x to those two values, but we don't need to do that. So this is probably the messiest any calc problems are going to be getting using product and quotient rule. Do expect to see the combination of these rules too. That's not uncommon to kind of use them in tandem with each other. But these rules, product and quotient rule, will be fundamental in finding the derivative of almost any function that you're faced with. So I hope you were able to grasp these new concepts with at least a general idea of understanding, and that I hope that you enjoy it. Honestly, I hope that you're like me and you really find the whole idea, the whole field of calculus is so interesting and intriguing. And every new thing that you learn is a new adventure, right? So thank you for watching, and I hope to see you in the next video.